Yeah, thank you, and thank you, Ron, for having me here, and special thanks to Steve Reed from Microsoft for the great demo, and actually hitting some of the points that I'll be delving into as well. So my name is René Wagner. I'm the business development director with TSRI, and I've been with the company for 14 years now. Been involved in large-scale modernizations, mainframe modernizations, all kinds of different environments to the cloud, to the Azure cloud, to the Oracle cloud. And I really bring this solution to customers all around the world. So banking customers, insurance customers. We've really done quite a wide variety of customers, from nuclear weapons on submarines to retail systems and banks, all around the world. It's pretty cool to see who we've helped out in the past. So I'll jump right into the agenda. So like the first thing, just like Steve mentioned earlier, I'll be talking about the reasons why organizations want to modernize or migrate. I'll talk about those 7 Rs that Steve mentioned. Specifically, I'll be agnostic. We focus on refactoring, but I want to make sure that customers can see what else is available to them. I'll walk them through a modernization journey, all the different phases and what to look out for and what to consider. And then I'll focus on the refactoring pattern, something that we do here at TSRI. I'll also talk about the differences and the benefits that you get when you do refactoring modernization. Then I'll go into risks and challenges. Steve mentioned quite a few of those. I'll drill down into what we have seen here in the last 29 years, having modernized almost 300 major modernization projects. And then I'd love to, get your questions and answer them as best as I can. So jumping right into why modernize. So there are tangible reasons and intangible reasons. And cost, while it's a big reason, it's not the only reason. Innovation and agility is actually what we see in the market a lot too. So, the rapid development and the deployment of new features. When you are in a legacy language and you don't have the resources, the COBOL or the PL1 or CA ideal developers, it's very difficult to, compete with these new solutions that are out there, like Rocket Mortgage and, Venmo and these new applications that were written from scratch. So it's very difficult to be agile and adapt and offer your customers these features. Total cost of ownership, of course, that's a huge reason. I mean, we see, and this is the industry average, between 60 to 90% of total cost of ownership reduction. That actually includes, the infrastructure, it includes third-party licensing, developers, and resources. So that's a huge reason for people to move to the cloud, to the Azure cloud, to get those savings. The next thing is the resource and the skill gap. So the developers, the COBOL developers that we encounter, sometimes they're coming back from retirement age. They are, we call it a silver tsunami that was coming over the last decades. They're aging out of the workforce, and they are key people in the organization that are necessary to, continue maintenance and development and, create new features in the COBOL or PL1 or CA ideal mainframe applications. So, when you modernize or you migrate, and especially when you do a refactoring, you get that opportunity to use modern resources and less costly developers, as well as tools, security tools and code quality tools and automation tools, CI/CD pipelines, things like that. One of the other reasons to modernize is scalability. So the mainframe is super fast. It's actually very reliable, and it does what it needs to do very, very, very well. But sometimes you are merging with other solutions or with other organizations, and you're taking on more customers than you can handle. The cloud, like the Azure cloud, will actually enable that dynamic scalability. And you don't have to pay on MIPS anymore or on peaks, but instead you can pay as you go or as you use. So that's huge, especially as your business grows. Risk management too. So, you know, security is at the forefront of a lot of these organizations, but also the operational risk. You know, if you're slowly losing all your subject matter experts, it's a huge risk to the operations of your business when you don't have anyone anymore that knows this application or these portfolios of applications. So that is also a huge reason. Reliability and resilience, you know, those are amazing features of the cloud and these on-prem and public and private clouds. You know, with increased uptime, availability, and very easy disaster recovery. So the mainframe also has very high uptime, but when it goes down, and you don't have another cloud instance that you can just switch to. So that is huge, especially if you know you don't have those mainframe resources or admins. And the other thing is vendor lock too. So with a lot of different mainframes, you know, we talk about the IBM Z, we talk about the mid ranges, but there are other flavors like the HP Nonstop Tandem mainframe or you know the Bull mainframe. These are all you know licensed operating systems. They have you know third-party utilities and middleware components that cost a lot of money. So when you do a modernization, when you do a refactoring, you can go to these open systems and utilize the open source tools and also go to something that's license free. Especially if you can get all the code and you're not limited by black box libraries. So those are some of the reasons and the outcomes that you have when you do a modernization. So I'll go next into the migration patterns, and Steve actually hit quite a few of them already. I'll talk about the 7 R's that are available to you. But really the first thing that any organization has to consider is, you know, what are my goals? What's going to happen with this application? It's been running for 30 years, 40, 50 years. Do I just want to retain it and do nothing? Or will I sunset it, you know, in a few years and retire the application? Great. Or do I have to sustain this application and this business line? Well, in that example here, we can rehost or relocate the application. So lift and shift into an emulated environment where, you know, we mentioned that there's very minimal change to the COBOL, for example. It is a COBOL to COBOL conversion, but it is very, very low lift when it comes to no changes to the code. The other one is relocate. So we see that with a lot of modern applications, like taking it from VMware and putting it into the Azure cloud. So a hypervisor lift and shift. Those are available, and those work especially if you have those resources still available. So, you know, tons of COBOL developers or mainframe folks.
Hey,
The second,
Renee.
yeah,
Renee, one
absolutely.
thing, just I
Hmm.
know there are a couple of questions just to do a quick level set. When everyone's here talking about mainframes,
Yeah,
it is not just the IBM Z.
that's right.
You know, just so we do a quick level set, the tools offered by Microsoft and the services offered by TSRI could cover a range of different solutions. I was thinking back, I mean, I'm sort of old these days, but you can go back to things like Sperry Univac mainframes. And I was just
Backs,
reading
yeah.
about Fujitsu mainframes are getting out of the business. You could talk about, you know, some of the HP tandem nonstop computing or the HP 3000s, the mini computers. You know, what we're really in broader strokes, I mean, mainframe
Yeah.
is a little bit of a catchphrase, my marketing phrase, but you were really talking about here for everyone listening is when you just got these old systems running COBOL, Fortran, whatever code you want to do, where there's a growing shortage of experts, and you don't want to be dependent on that one person getting sick on the day when something goes wrong. And that's really the premise of what TSRI and Steve can do across many different platforms.
Yeah, absolutely, Ron. and even rehosted, COBOL that was temporarily rehosted to achieve those mainframe savings. Like we've done projects like that too for telecommunications customers. Absolutely. Mainframes, mid-ranges, and even modern languages like Java or C Sharp. Java is as old as TSRI, 29 years. So that's absolutely, legacy code as I think about it too. The other pattern that we have available, to our customers is when they choose to optimize the application. So there are two ways, which is
Hey,
a
Renee,
replat. Yeah,
I just started interrupting. I know Vern, who's with Old Dominion,
yeah.
leading a financial institution, had asked specifically about IBM and
IBMI, yes, the mid range, absolutely. So I think Old Dominion, you have RPG 3 and RPG 4. So those things can be modernized to Java, for example. Absolutely.
now, Vern, I want to make sure I just unmuted you. I'm not sure if you can speak, but I just want to make sure we answered your question. If there's anything else you want to add, either verbally or in the chat, you can type it in, but let's keep going. But the
Okay,
answer is
sounds good,
yes, it
Ron.
runs IBMI. And Vern, if you, I'm gonna unmute you now, but if you do want to share anything, just let me know, and we really appreciate those questions.
Great. Thank you, Ron, for mentioning that. So in the optimization line here, or that you see, there's a replatform and a repurchase or replace R, like migration pattern. The replatform basically means you're lifting and shifting the application with parts of it reimagined. So parts of it being rewritten and just making, minor adaptations so that you can actually replatform and put it on another platform. The other one is replace or repurchase. So usually what we see is custom off the shelf solutions that will, be customized after they're deployed. So it doesn't make sense for, a bank to translate a CRM system when solutions like Salesforce or other CRMs are available to you. You just have to purchase that solution, replace it, and customize it to your business needs. And then the last migration, last but not least, is the refactoring or the reimagining pattern. And that's where TSRI falls in, where we automatically refactor the application into a new programming language, a new database, a new architecture, and the same look and feel for the user interface. So those two things are available to you in this refactoring pattern. The reimagining pattern, that's basically rewriting it by hand. And if you have small applications, that makes sense. If the application needs to change 90% of its functionality, absolutely, a great solution to rewrite it and adapt to those business needs. But if the application does exactly what it needs to do and it works well, it has your intellectual property in it and your business logic that you rely on, and you want to go to the same application in a modern architecture, with a modern database and a modern language, we can automatically refactor the application. And I'll go into the refactoring pattern here in a little bit, but let's look at the modernization journey. So this actually applies, the majority of this applies to all the patterns. So the very first thing is to do a documentation, an assessment, and really define your goals and outcomes. So what is it that this application needs to do in the future? Like, will it be still around in 20 or 30 years? Does it do what it needs to do for you? Or can it be replaced with a COTS solution? One thing that's also important is to get the buy-in by the stakeholders. So strong governance and software advocacy is very, very important. So before you do, any migration pattern, the team needs to be on board so that it will be a successful project. Then you assess, you advise the customers, you use systems integrators and consulting companies to really identify what is there. Like, what are the things that I have? What are the technologies? Where do they interact? What are the integration points? How much testing do I have already available to me? So all that assessment, that discovery has to happen in order for the organization to decide on that migration pattern. Is it a refactoring? Is it a rewrite? Is it a COD solution or a rehost? You have to decide that when you define your outcomes and your goals. And then a lot of times, just like Steve said a little bit earlier, a lot of times customers don't have any documentation, and the knowledge is stuck in the heads of the subject matter experts of the legacy system. In that case, what we also provide is code documentation. And we actually have a service, a self-service model that's hosted in the cloud, where you can just go upload your code and get that documentation. So that's huge. And I can't tell you enough how important that is to an assessment and discovery phase. The other thing that comes out of that, working with the customer and cloud economists, is a business case or total cost of ownership analysis. Like, what will my spend be in the cloud? What will my savings be? Will it be, 60 to 70%, or like we've seen it with some customers, 90% and higher? So that will be very important for the business stakeholders and the CFO to actually make a decision. And then you get into the architecture design and planning, as well as mapping the externals. Because code is just one aspect of an application. What about the utilities, the IBM utilities, the HP Nonstop utilities, the middleware that this application is relying on? All those things need to be moved as well in order for it to be a functionally equivalent application. And in the Oracle Cloud and in the Azure Cloud and other clouds, they actually have perfect replacements already available that are very, very inexpensive. So other areas for savings for an organization too. So once the refactoring pattern has been chosen, then we actually, here at TSRI, we get to work, we transform the code, we transform the databases, the screens, we transform it to a functional equivalent application and replace those externals and do specific refactorings that are, good in general for your developers and the people that are now going to maintain this Java or C# application, but also specific pattern-based refactorings to remediate security issues. Like right now, the mainframes have SQL injection patterns that are actual vulnerabilities. So we, with our refactoring capability beyond that code conversion, can actually refactor those out with automation. Same with performance. When you go from a mainframe where everything is on one box, super fast, and you go to a distributed environment, you need to account for performance, even physics, because users could be in Brazil and the database lives, in a different availability zone. So performance refactoring is important, as well as utilizing solutions like caching and things like that to get the same or similar performance. And then go one step further, identify services that can be, made into their own modularized, microservice, for example, and do custom automated re-engineering. So we have a lot of customers that want to go beyond just code conversion, and they have problems with their database layer, or they have something that they want to introduce with automation. So in that case, we build patterns and rules to apply a remediated pattern against that code. But that's not all. And like Steve said earlier, a big part of a modernization, and unfortunately a big part of manual efforts, is the testing and the integration. And in fact, that is the longest pole in the modernization timeline. So implementing the services, implementing that middleware, testing it, integrating these externals. Some applications have 10 externals, others have 2,000 externals. So you have to account and uncover those in the documentation and assessment phase in order to map them to cloud services that are available in the Oracle and Azure cloud. And then what we always stress to our customers is think about whatever you can automate. So automated CI/CD pipelines for automated deployment, automated testing, automated unit test creation, using GPTs and AI, Gen AI, to actually get insights into the code, like Steve showed us, and derive specific test scenarios. And then we also focus on, multi-cloud deployments and going very cloud native. So, cloud formation templates or, terraforming is what it's also called, to actually deploy very quickly the modernized code can be very, very advantageous too. And then one cool thing that Oracle and Microsoft are doing, they are really enabling the customer to see all their cloud resources, even the other clouds in their one cloud console. So you can track, your spend, you can track your utilization, and that's really nice as well. And then the innovation after the application is modernized. So of course we support the modernization afterwards too. But when I think of modernization, really it's a continuous thing. Like as soon as you put something into production in my head, that's actually, legacy. So retransforming the application or applying other refactorings, hooking into your CI/CD pipeline to, continuously make your application better. That is, I believe, also a key part of the modernization journey. Same thing with documentation. We said a little bit earlier, the knowledge is stuck in the few people that know the mainframe application or the mid-range. So providing that continuous documentation and following your release cycles is really, really important so that you have great insights into the code. So that's the modernization journey. I don't know if there are any questions on the modernization journey, but I'm happy to ask them before I go into how we do what we do and why it's different to what you might have seen before.
I think we're good. I think it'd be
Okay.
really valuable, Renee, for you to conclude and show some real life examples of how you make this
Yeah.
work for clients.
Yeah, absolutely. I actually have a banking client example of a modernized application here in a second. But focusing on refactoring, what we do is we take in the legacy or the mainframe artifacts like the JCL, the PL1, the COBOL, the vsem files, usually not the data, but the DDLs, the database schemas, the BMS maps, the MFS screens. And the first thing that we do, and it's a big differentiator, is create a model of the application. So this is not a line-by-line conversion. This is not a transliteration, which you might have experienced before, that creates COBOL code. It does generate code, but it is maintainable and being maintained by our customers. And everything really revolves around that model. So generating documentation, generating code, cool, other people can do that too, but actually refactoring the code to remove these COBOL design patterns, go-to statements, perform loops, Y2K problems. We do that with automation, very high degrees of automation against that model, which allows us to not ask the customer to freeze the code or get new baselines during the project and even after the project too. It also allows us to derive documentation as is documentation, which customers actually purchase without modernizing, just to have their current application documented. And then also a transformation blueprint, which what we call our to-be documentation. It shows side-by-side code. And whoever is interested at some other session, I can show you some actual COBOL modernized to Java or C#. So you can see what the quality is. And then ultimately, what do you end up with? Well, you end up with a functional equivalent application in a modern architecture and a multi-tier cloud-native architecture. So not a monolith, not a spaghetti application. You'll have a unified code base, and with us, there are no license fees, and we provide even our framework code in source code form with documentation. So that's huge because the golden handcuffs are off. There's no vendor lock with our solution. So I want to drill into this refactoring pattern and actually talk about a concrete example of a banking application that was around 5.1 million, 5 million lines of code that we've modernized from COBOL to Java. So this is usually, these are two Sonar Cube scores, and this is usually the first one over here. It's usually where other modernization vendors stop, where there is Jobal code. There are a ton of vulnerabilities, lots of code smells. In fact, these 98,000 vulnerabilities and code smells would have taken 24,500 human labor hours to be remediated. So that's a huge amount of technical debt and duplication that would have remained in the application, where you would have thrown, developers, armies of developers at this to remediate that. Well, we were able to remediate that within less than 23 hours of writing refactoring rules against this model that I was speaking about earlier. So with that same automation, truly 99.9x% and higher against entire code bases and even subsequent applications. Because when we write a rule and we apply it against the first application, it can be reused, which makes this really attractive to enterprise level customers. So that you end up with 0 vulnerabilities, and the majority of code smells actually remediated. And all that within 23 hours of us and our genius people here writing these refactoring rules instead of manually touching the code. So that is a concrete example of a banking customer that we've modernized and that's in production. So what are the benefits to the customers? I mean, the automated documentation and the automated transformation really reduces the maintenance costs and allows you to onboard, resources, new resources faster. But it also helps you, even if you just buy the documentation, get insights into this application. The other thing that we support is not a big bang. It's one of the riskiest part, in my opinion. We actually do an iterative and graceful migration. So we can show early success, incorporate feedback in the different sprints or spirals, and really get you the best code out of the other side. You also have a faster time to market with these features. So, something that would take humans, decades to rewrite, we can do in a matter of months. Because we have that, higher than 99.9x% automation. We'll also have less defects, which, humans introduce defects. If you have a very automated solution, you get, very few defects. We'll also have a transformation warranty where we'll warrant the code to be free of any transformation related errors. That's how accurate we are. And all code will be transformed at 99.9x% automation. What that actually, means for the stakeholders, the business stakeholders and the organization is huge economies of scale, a higher reuse factor if you have multiple applications. And what we see, I talked about the industry here earlier, but what we see an 80 to 90% total cost of ownership reduction, and with us, no license fees. So no more vendor lock or black box libraries. I was mentioning, we go to a very cloud native deployment, fully containerized, service enabled. There will be a REST layer. It'll be, in a very cloud native architecture on Azure and OCI. And because we don't focus on that code, because we don't do this line by line conversion, we actually don't ask our customers to freeze the code. So we get code baselines throughout the project, sometimes dozens of code baselines, updates, so that we can do the modernization in parallel. And even if you tell us, hey, I want to make a specification change in sprint number 4, we can actually apply that to all previously modernized code. So that's really powerful, especially if you have a large application where you can disrupt that business, which helps us accelerate the actual modernization and reuse those actual rules. And also we go beyond this code conversion, and we do that technical debt reduction. We increase the maintainability. We introduce new, what used to be ABC 123 COBOL type can turn into something that a normal person can actually read, like a normal modern developer is what I mean. And increase security and performance, because that's really important to our customers. And then lastly, we have this unique capability of a dual database layer where we introduce and encapsulate data and database calls, which allows us to target the legacy and the target database. So we can actually move not only parts of the functionality first, like online first and then batch, but we can have it still talking to the DB2 database, for example, and then in the end, move the DB2 database to Microsoft Azure managed SQL instance. And that allows us to do that gradual go live and really reduce that risk and show early success, because you don't want to wait 10 months for all the code to be transformed. You want to see something fast and have your high priority modules, your biggest spend, be modernized first. So that's my last slide here, where I now want to enlighten you a little bit around the risk and challenges and how to overcome them here. So one thing to consider is complexities. So we see a lot of applications that have, for example, code generators within them, or they have externals, external interfaces where a replacement doesn't exist anymore. Well, before you get into a project, you definitely need to assess that application and do that planning. Measure twice and cut once is really the principle here, so that you can actually have a successful project. Quality too. I mean, when you modernize that application and new developers will have to maintain this application, be a nightmare if it's a procedural spaghetti application that's still a monolith. So that's where I always stress the difference between using model-driven tools and rule-driven tools, like the TSRI tool, versus the transliteration, the line-by-line conversion, where you end up with this COBOL or COBOL-looking C# that has the same underlying, legacy COBOL undertones or design patterns. Testing too. Testing and integration are probably the biggest risks to a modernization. If I can give you any advice, if you're considering rehosting or refactoring or rewriting, immediately start recording test cases, because that will be the longest part of your modernization. So test planning, creating the baseline comparative tests, and automating what you can within the cloud, for example, or in your recordings is huge. And we have some automated ways to derive test cases, but a lot of it is really driven by your organization's SMEs too. There's also cultural resistance. So that strong governance and software advocacy that I was talking about a little bit earlier is huge also, because you can't get into a project where half the people, the stakeholders are naysayers and are not comfortable and have that warm and fuzzy feeling to actually do the modernization. So that cultural resistance and incorporating these COBOL developers is huge, because they know the application, they know the functional parts. They are there in a huge way to actually bounce ideas off. So very, very important. And then also the vendor lock. So, going from, like I said, the IBM mainframe or HP nonstop, where you're locked down by these licenses, to yet another license solution. In the long run, that will cost you more money than going to like an open solution where all code is available and where you can utilize open source software or license fee fee-free products as well. This should say license fee-free. Skills gap too. I mentioned it earlier, it being a problem because you might not have, many COBOL developers or RPG developers. In the new application, you still have to onboard, new Java developers, and they have no idea of the system. So they need that insight, that upskilling and that training and the knowledge transfer through that documentation I was mentioning earlier, what we call our transformation blueprint, to get that insight into the application, work with the hopefully COBOL business analysts, the people that know the application, to gain that insight. So those are usually the risks and challenges that we've seen in over 300 modernizations now. And I'd love to address some questions. Otherwise, I would hand it over to our friends Manish from Microsoft and Chinmay from Oracle.